everybody, welcome to Thursday. Hope you guys are having a good week, learning some things. I'm sure you guys have all heard already by now that we're not going back to school, which is crazy. I just want to make sure that you guys are keeping on top of your assignments. I know I've talked to a lot of your families. If you're falling behind or whatever, just make sure you email me if you have any questions or if you need clarification on what you need to do or you're not sure where to go to find what you need to do. All right. So today, well, I guess this week in general, we've been talking about Pythagorean theorem to find that missing side of the right triangle, right? And just to kind of run through one of those, what they look like again, in case we're not doing so great. A couple of you made some mistakes, which I tried to explain during comments on Google Classroom. I know that's a lot harder than me just coming over and showing you what to do. But when we have this right triangle, right, and I know this side is 33 centimeters, and this side's 41 centimeters. As long as we know a right triangle, the thing that you got to be careful about again is looking for that hypotenuse. The hypotenuse is always the one that's across from the right angle. So when I write out my Pythagorean theorem, a squared plus b squared equals c squared, c has to be this hypotenuse side. A couple of you put in wrong sides. I commented back to you. Remember, these two sides have to be a and b. So in this case, we would just go 33 squared plus 41 squared equals c squared. And then grab my calculator. 33 squared, 1089. 41 squared is 1681. We still don't know c squared, so we're going to add those two together. It gives me 2770. And then the only other place where I really saw some mistakes, be careful here. Remember, when you square root something, you're not dividing at all, right? Square root is its own thing. So use your calculator. Hit the square root button first. Or some of you, your calculator, you have to hit it after you put in the number. And this time, C is about 52.63 centimeters, right? And remember, you can round this to the hundredths. That's probably the best option for you. Some of the stuff on Pearson said to the 10th, which is fine. But in general, the farther you go, the more accurate your answer is going to be anyway. So that's definitely good. All right, so that's what we've been talking about this week. Today, in particular, I'm going to talk about the converse of the Pythagorean theorem. So converse is kind of like the opposite. So, for example, think of an if-then statement. So, if I go outside and it's really sunny, then I'll get a sunburn or something like that. The converse of that statement is you put the then part first. So you flip them. If I have a sunburn, then I must have been outside in the sun. Okay? The converse of the Pythagorean theorem, it's the same math, which is great, but it's going to try to show me if a triangle is in fact a right triangle. So, for example, I have this triangle, and I don't know if it's a right triangle. It certainly looks like it might be a right triangle. And so now I know some sides of it. So let's say this side over here was 15 meters, 20 meters, and this side's 25 meters. And I want to know, is this triangle actually a right triangle? Well, to figure that out, we can use the Pythagorean theorem, right? So we said if something was a right triangle, we could put the legs in for A and B. We could put the hypotenuse in for C, whatever we need to do, and do A squared plus B squared equals C squared, and figure out the missing side. This time we don't have a missing side, right? We know all three. So when I'm using Pythagorean theorem here, I know that if I finish this and I have a true statement, right? So maybe I have 90 equals 90 or something like that. If that happens, we have a true statement. That means, yes, this triangle was in fact a right triangle. But if we have 90 equals 110, that's not true, right? That's a false statement. So therefore, wow, my wife's having troubles. Let me see it. Therefore, if it gives me a false statement, then we can say this is not a right triangle. It's some other kind of triangle. We don't know what kind of triangle it is, but we know it's not a right triangle. So, things that you want to be aware of. If this is a right triangle, we don't know if it is, but we know that the longest side has to be the hypotenuse. So when I look at my three lengths, the one that's the biggest is going to have to go in for C no matter what you do on this problem. So this one is going to be C. And we don't care, again, if 15 is A or 15 is B. But we know that those two numbers have to go on this side. Okay? From there, let's see, 15 times 15 is 225. 20 times 20 is 400. 25 times 25 is 625. Right? So, I squared all of these numbers like it says. Now we can add those because they're like terms. 400 plus 225 is 625. 625 equals 625. That is a true statement and does in fact equal each other. So we can say this triangle is in fact a right triangle. And that's how the converse of the Pythagorean theorem works. So I plugged in all my numbers. I used the formula. I got down to the same number on both sides, which then I can determine, yes, this is a right triangle. Right? So when we talk about the converse of the Pythagorean theorem, we're only trying to see if a triangle is a right triangle or if it's not a right triangle. That's our conclusion's always going to be something to that nature. Let's try another one. How about? We'll say this one is 62 inches, 79 inches, and 100.4 inches, something like that. All right, and we want to know, oh, my bad. We don't know that yet. We want to know, is this a right triangle? We don't know if it is, but we're going to use the converse of the Pythagorean theorem. So, a squared plus b squared equals c squared. We find the biggest number over here. That's this one. That has to be c. Those two, doesn't matter what order we put in. So we'll go 62 squared plus 79 squared equals 104 squared. Awesome. Now, square our numbers. So 62 squared, 3,844. So, I don't like that. 79 squared, 6,241. And 100.4 squared is 10,000 80.16. Awesome. So we did all the squared parts. Now, again, we have like terms, so we can just add those together. So let's see, 5, 8, 0, 10. So, do these two numbers equal each other? Well, 10,085 is not the same thing as 10,080.16. They're very close. That does not matter if they're very close. They have to be exactly equal. So, in order to figure that out, look at them. If they're not exactly the same, we would just say this is not a right triangle. And you could do like a little sad face if you want. All right. Okay. So that is basically the converse of the Pythagorean theorem. So tomorrow we're going to do kind of like what happened on Wednesday, which will be, you'll have a Math Excel, you'll have examples from the book. But for today, I'll just give you one. And I want you to prove that this is a right triangle or prove that it's not a right triangle. So you guys can try this one. And let's say, we'll say this side is 26 feet. We'll say this side is 24 feet. And this side down here is 9 feet. I know that it doesn't look like that's the case, but let's just go by the labels, right? So yeah, tell me, is that a right triangle? All right. Hopefully, you guys will be okay with that. I'll try to get back to you, look at your problems, and leave you some feedback. Tomorrow, Math Excel. Hopefully you're all excited because the Browns pick really well. And the Niners. And my wife is super excited that Tom Brady's on the Buccaneers and Gronk and what is going on? All this Corona stuff. I don't know. All right. I'm done. Have a good day. See you guys later.